This video will be the first in a series of videos on the conversion of a Precision Mathews model PM-30MV Mill for CNC operation. First of all, I'd like to thank the other YouTube authors who have completed videos on this topic. Again, they've been very helpful in giving me a lot of guidance in the conversion of my PM mill. As part of this project, I'll be creating a series of web pages on our website. These pages will contain a list of all the videos I'm producing on this topic, a list of other related YouTube videos, a list of reference materials such as schematics used in the production of the CNC conversion, a list of other reference materials that can be helpful for this project, and a list of all the materials and parts used and where you can get them in the conversion of the CNC mill. This page is meant to be a reference source for other persons who wish to make a similar conversion of their mills and lathes for CNC operation. In a previous video series, I automated a bandsaw for the slicing of wood boards using the Accu-Slice system. For this automation system, I use stepper motors. Visit our website for additional details. To convert the mill for CNC operation, I'll be using the Centroid Acorn software and control board. I'll be using the Arizona CNC double ball screws, and I'll be using the DMM model DYN4 AC servo motors and drives. After reviewing the other software and hardware systems available to operate the CNC mill, and reviewing the comments of others who have made similar conversions, I decided on the Centroid Acorn software. Other systems such as the Mac 3 and 4, as well as Linux, were also considered, but the Acorn system appeared to be more reliable, easier to install, and highly rated by other operators. Shown here is the main screen for the Centroid Acorn website. I debated for a while if I should use closed-loop stepper motors or servo motors for this conversion. All of my experience to date has been with stepper motors, which I used for my automated Accu-Slice system for the automated and unattended bandsaw. However, after reviewing the comments of other operators and after a discussion with Stephen at DMM Technologies, I decided to go with the servo motors. The servo motors will run quieter and cooler and should be more reliable. My concerns in this selection were that the servo motors are more costly and I had no experience using them. But I think the advantages of the servo motor should far outweigh my reservations. My first thought was to use the existing Acme screws that were installed in the mill, but apparently these are not accurate enough due to significant backlash. My hesitation was the thought of installing the new ball screws on a mill that weighed over 500 pounds. Since this mill will be in my basement shop, and I alone will need to do this installation and conversion. But the ball screws will have less backlash and will give more accurate results. After reviewing the comments from others who have made similar conversions, I decided to go ahead with the double ball screws. Again, I reviewed the double ball screws from various sources, including Arizona CNC, Heavy Metal, and several other companies. And after several email communications with Arizona CNC, I decided to go with their units with the double ball screws. I'll begin this with a description of the electronics systems, which I laid out on the board here. Originally, I ordered a smaller control box for this system, and all the components would have fit in that box, but it would have been very tight and the wiring would have been a disaster. So I ordered a larger control box, which now is 24 inches wide by 30 inches tall. And everything fits in here quite nicely, and I have these wire guides now that I can run the wires in and keep things much more organized. In addition, I have enough space left over to add an additional driver if I want to add another motor for the spindle operation, which I may do in the near future. As part of the control chassis box, I had ordered this back panel. I spent a good deal of time determining the layout on this board for all the components. I want to lay out all the components in a logical pattern with wire guides to provide for a clean assembly of the system. There will be a lot of wires for electrical hookup of this system. I want to keep these wires organized and easier to manage. I also want to keep the Acorn board further away from the main power components to avoid any electrical interference. I'm also using a number of terminal blocks, including a main 120 volt input power set of blocks, common grounds, and the 24 volt and 5 volt supplies. On this left side of the board are the power supply, the 524 volt DC power supply, the Acorn board, and the relay board. Right now I'm powering the system up to have 120 volt operation, but I may change this to 220 volts in the future. the power will come in through the top and then go to this terminal block. From here, the power will be directed to the system to control the servo motors. The power will go through a number of components for these servo motor drivers. These have all been laid out in a concise straight line and organized pattern on the back panel. I start with the circuit breakers, followed by an EMI filter, then a contactor, an additional EMI filter, and then finally supply going to the servo motor drivers. In addition to wiring these components, I'll also be adding a main power switch with an indicator light, a cooling fan to cool the drivers, and a quick e-stop for the quick remote stopping of the system should that need arise. On this left side of the panel, I've laid out the 24-volt DC power supply. This is both 5 volt and 24 volt, but I don't think I need the 5 volt for the system operation. Then I have my Acorn control board, followed by a relay board. I'll be using a Centroid computer system with a touch screen and a Centroid software to control the entire system. So next I'll begin with the wiring. I'll be using the electrical design schematics from DMM Technologies and Centroid to wire these components. These schematics are listed on the web page as mentioned earlier. There'll be a lot of wires for this assembly, and I hope these wire guides help keep them organized. I'll be using 14 gauge wire to power the components for the drivers, and I'll be using 18 gauge wire for the other components to the Acorn and relay board. I'll be using crimp connectors for most of the electrical connections, but I'll also be soldering all these connections to assure good connections. I'll be doing the actual electronics assembly off camera, since it's going to be time consuming and tedious doing all this wiring. But I will review the wiring in the next section of this video when it is complete. This will be followed with some bench testing of the parts to make sure everything is operating properly. I just finished hooking up my X and Y axis and getting the bugs out of the system. I was having quite a bit of a problem for a while, and it wasn't the servo motors weren't working. And I went through a lot of issues trying to figure it out and ended up rebuilding the whole system. And what I ended up finding out is these EMI sensors cannot be grounded. If they're grounded, it doesn't work. So I'll be mounting them on a plastic strip here to keep them isolated from ground. But that solved the problem. So going through my circuit, I have my power coming in here, going to my circuit breakers. These are EMI filters, which apparently grounding is not a problem with those two. And these are my contactors. And these are the second set of the EMI filters. And now I'm just hooking up the final cables for these EMI filters. Okay, we'll run the DMM driver program. Connect. I know I'm connected to port 3. Let me go to servo setting, DYN4. Now we can read our drive. Okay, so it's in RS-232, pulse position servo. I should be able to check my motor to see if it works. And it does work, reverses. So that's good, it's working. So now I want to change my system to operate it. So I want to go to pulse directory, use that where it is. Servo enable active low needs to be checked. Changes net gain to 2000. And the line number to 2000. Yeah, I want to save that. Read it back to make sure it's there, which it is. I'd like to save it again just to make sure it's there. And that should be done. And nothing else to do here. Nothing else I can do here at this time. So shut that down. Now I'm going to restart the Acorn system. And now we're on the CNC 12 software. I'm going to go to the the wizard. Okay, going down my access drive. I'm using the DYN4. I have my IN5 set to normally on. When I first started running this, I was getting a problem. It's because I was getting a drive error because I had this set to normally closed. It should be normally open. But my e-stop should be normally closed. And I have no output definitions at this time. Now we go to axis configuration. I want to add my z-axis. Change my steps per revolution to 8,000. And changing nothing else at this time. Write those changes to my system. Okay. Not do anything here. Here I need to go to advanced. And I need to turn this Axis 3 enable off. In a previous video that Marty had, he had to turn that on, but when I tried turning it on, it didn't operate. So turning it off made it work properly. So I'm not sure what the issue was, but leaving it unchecked seems to work for me. And setting this to 400,000. We have 2 or 3 options. I'm using 400,000. And I want to save those settings. And that should be it for here. I now have my z-axis here. I need to restart the system, so let me exit it. And let me restart Acorn also. I wait at least 10-15 seconds between starting or stopping it and then restarting it. Wait for my heartbeat light to come on. Okay, my heartbeat light's on. Now we can start the CNC 12 software. Press declare. Cycle start. Everything went to 0. So, I'm in continuous mode. X. Working. X negative. Working. Y. Working fine. And Z. My system with the 3 drivers and the 3 servo motors has all been set up and working. Everything's been tested. Everything's working fine. But I'm going to do one additional modification. I want to move some components around a little bit. I want to make some larger guides for my wires. I want to move these drivers a little bit closer. I'm using a single fan. And originally I was going to put the fan inside the box, but now I'm going to put it outside the box. And so this fan will vent all 3 of these drivers. I'm going to move a little closer together. That's one step I make. I'll be mounting my EM filters on an insulated pad and getting ready to do my wiring. So I'm not sure exactly how all the wiring is going to go, but this cabinet will be mounted on the left side of the mill, and so my wires for the drivers for the servo motors will go out the right side of my cabinet. The power will come in from the left side and come in through the top on the left side. So my main power will come in up to the top. So power coming in there. I'll have a vent on top for the exhaust fans, and these cables for the servo motors will go out this side of the cabinet, either the bottom or the side. I'm not sure which yet. And that's pretty much it. So I'll just do one final disassembly of the system, and then recheck all the wiring, make sure everything's kosher, do a final test, and if all that checks out, I'll actually mount the cabinet on the wall and put this panel in the cabinet and do another test to make sure it's all set. I just completely redid the system. I took it all apart, moved a couple components, changed a bunch of wires. So let me show you what I did to make the changes. I started off by putting larger wire guides here, so there's much more room now for my wires. So I can go and cover these up. So it cleans the system up quite a bit. I did move some parts here to give me move things down a little bit. I moved my drivers down closer to the end, give me a little more room. So just spread things out a little bit more, gave me a little more room. I did add another terminal block. This is for the wires coming from the drivers, because I had 3 wires going to pin N5, and another 6 wires going to the 24 volt supply. So rather than have all those wires go into one connector, I put a terminal block here and wired them to that. It actually looks messier than it did before, but at least it's organized. There's a lot more room here now. These drivers did move down, so my fan now will be outside the box just about here. And I did move these over, so the fan will be blowing across all 3 of these. So I'll make a box to cover that as I go forward. I did add a remote e-stop. So this e-stop goes to my IN8. It also controls the contactors. It drives the power across these solenoids to activate the contactors. So that's all set up. And I have probably about a 6-foot cord on there. I may change it to a larger one later, but that's it for now. The only thing it's not done, I did not put fuses in the lines going to these drivers yet. I had them on order, they haven't come in yet, but I will put those in as soon as they come in. I just checked the system out, everything works perfect. So I'm ready now to start on the case. So I'll be working to mount this in the case, drill holes for the fan, some of the wires coming through. Switch, I have an on-off switch that I'll be putting on there with a power light. So that's the next step, is to start working on the case. Okay, I just turned on the Acorn system, powered up the computer. Press reset to clear. 0 on my XYZ. Everything's set. So let's go ahead and run a sample. And let's do a G1, X2, Y2, Z2, and we'll do a feed of 10 inches a minute. And we'll go ahead and run that. Everything's working fine. Motors are all running. I mount the cabinet on the wall with some light bolts, so it's attached right to the studs. I have various holes just for the electrical box, the cables, all my servo motors will be going through these connections. My e-stop will go through here. I also have a hole here for a light, and electrical coming in this area. My fan's mounted on the outside. I'll have to make a box to go around this eventually. And so now I'm ready to put the panel with all electric components in the box. Now I'm ready to start doing all the wiring. Well, I got my power hooked up, and I want to verify that I have my hot wire going to my top set of terminals. And this will be my neutral, and then of course I have my ground. So my meter hooked up to my ground, and I'm pretty sure my black wire is my hot wire, so I just want to check it. Plug it in and turn the power on. And I have 122 volts going to the black wire. That's good. I then hooked the power cables to the terminal strips and powered on the system. Fan works good. I got plenty of air going through there. Okay. Let me unplug this once again. And now I can put the rest of my wiring. Yeah, I did change. I was usually having power come from up here, but my power has to go to the switch first, so I brought it in the bottom instead. So next time I'm going to hook up my e-stop. It's going back through here. I have grommet wires in all my holes to protect the wires so they don't get frayed. So this e-stop actually has 4 wires. 2 are for the contactors, and the other 2 are for the to go to the Acorn board. So let me start with my servo motors next. We'll start with X. This is the cable that goes here. I wired up each set of the servo motors with each set of the 2-wire cables passing through the holes with the rubber grommets on the side of the cabinet. One end of the wires was connected to the drive and the other end was connected to the servo motors. This was then repeated for the Y and Z drives. I then used some wire ties to tie together each set of the 2 cables to keep the system neat and organized. The last cable I installed was the Ethernet cable going from the computer to the Acorn board. Now for my feed-throughs through the cabinet, I selected to use these grommets, these rubber grommets. I could have used these aviation connectors, which a lot of people do, but I just decided just to use these grommets. And I did put some large wire ties so that the wires, they can't pull through. That protects those. But I just selected those to use rather than these. It's a little less work hooking them up. I need to do one thing more. I need to get some, they have some like Velcro strips that hold this thing down, so I'll get those hooked in. I have to order them. I don't have them in stock, so that's the last thing. So the next thing is put the door on, and let me hook the computer up, and then we'll start testing it for the 3rd time. Okay, the last thing is to put these covers on my terminal blocks, and then the covers for my wires. Okay, I'm all ready to test the system, so let me turn on the system first. Let it power up for a few minutes. I don't have access to my heartbeat, so I have to just give it time to make sure it's turned on. So let me go ahead and start up CNC 12. Reset to clear. Let me zero my XYZ. And now let's test the servo mode. I have X, Y, and Z. So let's put this in fast mode. X, Y, and Z. It all works. Now we're just ready for the mill to arrive. The mill's probably about 3 weeks out yet, so I'm all set for it. I got plenty of circulation. I can feel the air coming out of here. I do want to make a screen for up top and a box for around the fan yet. This whole system actually took me almost a month to complete. It took me about a week and a half to make my cabinets, and a whole series of cabinets for both the new lathe and the new mill, new countertops. And ordering supplies to get everything set up, and then learning the system and getting it installed. So about a little over 3 weeks total to get the system set up so far. But I still have the mill to get, which that'll take me another week or 2 to get that all set up. This completes part 1 of this video series on converting the PM-30MV Mill to CNC. Additional videos will be available in the near future. For additional details, check out the PM-30MV Mill CNC Conversion page on our website. Once again, thank you for watching this video. If you have any questions or concerns, please give us a call or send us an email. Thank you.